right, y'all. So we are going to be talking about Station 5. So Station 5 is going to be exploring that continuity definition. So I'm going to go through these three scenarios with you. Ooh, not drawing. I'm going to go through these three scenarios with you, and then at the end, I'm going to let y'all come up with those three things that make a function continuous. Now remember, they're the same things we went over in the notes, so hopefully you remember from the notes. Okay. So scenario 1, we're going to draw a graph of some function called f of x, where the function has a hole in it at x equals 4. So pretty simple. At x equals 4, let's see, 1, 2, 3, 4. Let's just stick a hole in some function. Doesn't really matter where. Okay? And then let's make it nice and linear, because linear functions are easy to work with. Just like that. Okay. So what is the value of f of 4? Well, we have a hole there. So what are the values at holes? Well, they're undefined. So the value at f of 4 is undefined. What is the limit as the function approaches 4 from the left side? Well, as we approach from the left, what y value does it look like we get to? Looks like 3. What is the limit as x approaches 4 from the right side? Well, from the right side, it also looks like we get to a y value of 3. So, once again, 3. Does the limit as x approaches 4, so if the left and the right are both 3, that makes the overall limit 3. So the overall limit is 3. Is that equal to the value of the function at 4? No, because the value of the function at 4 is undefined. So is this function continuous? No. Why is it continuous? Or why is it not continuous? Sorry. Because of a hole at x equals 4. Okay. Scenario 2. Draw a graph of a function where the limit from the left side is not equal to the limit from the right side. Well, that should be pretty easy. All we have to do is show some function where the left side limit and the right side limit aren't the same. Okay. So we want some kind of jump discontinuity, some kind of piecewise function going on. So let's go over to 1, 2, 3, 4. We'll go up here with one of the functions and down here with the other one. Once again, I'm going to make this nice and linear because linear functions are easy to work with. Okay, so we have our two nice linear functions, nice and easy. So what is the value of f of 4? Well, we do have a value of f of 4 this time. So f of 4 is equal to 1, 2, 3, 4. Does the limit as x approaches 4 equal f of 4? Well, we already decided that the left side limit and the right side limit does not equal. So what does that mean the limit as x approaches 4 is equal to? Should be does not exist, because if the left and right side are not equal to each other, then the overall limit is not going to exist. So does the limit as x approaches 4 of f(x), which is d and e, equal the value of the function at f of 4? Well, no. 4 doesn't equal, it does not exist. So is this function continuous? No. Why? Because of a jump discontinuity. All right, scenario 3. We're going to draw a graph of a function with a hole in it at x equals 4 so that the limits, the left side and right side, are still equal to each other, but that on our second point, there's still going to be a point there at x equals 4. So let's kind of do our very similar linear function that we did on that last one. Okay, so right here at 4, we're going to go up, do a nice little hole, but then let's stick a point all the way up here. There we go. Nice linear line. Too many lines. Okay, so what is the value of f of 4? F of 4 is all the way up at 1, 2, 3, 4, 5, 6, 6. What is the limit as x approaches 4 from the left? Well, I did a really bad job drawing, but let's say it's 3. What is the value as x approaches 4 from the right? Also 3. So our overall limit would be 3. Our value of our point is 6. So does the limit and the point equal each other? No. So is this function continuous? No, it's got that weird hole with a point floating above it. That doesn't make any sense. So why is it not continuous? The function value does not equal the limit. Okay, so those are 3 scenarios, 3 ways that a function could be discontinuous at a point. So now I'm going to let y'all do this on your own, but go ahead and come up with the 3 reasons that would need to be true, the 3 things that have to be true for a function to be continuous. You can cheat and look at your notes if you need to.